lesson is about finding the unit digit of a raised to b, where a and b can be any natural numbers. Remember, power a raised to b is eventually a multiplication, a into a into a into a. So let's start by finding the unit digit of a product. Let's say we want to multiply 837 into 52. Now, and I want the unit digit of this product. Now, obviously, you can go to your margins, take 837, take 52, do the multiplication, 7 to the 14, 7, whatever it is, put across, 7 to 35, 18, 41, and then add them up. So, you get a 4 out over here, and you get so on. Now, I am interested only in the unit digit. So, here is my answer, the unit digit. I'm not really interested in what these numbers are. So, why am I wasting my time finding these numbers, right? So, I'm not really interested in the complete product, right? So, these values are immaterial to me, whatever they may be, right? So, let me just scratch them out. I'm interested in just this one. And this is found by the product of the 7 into 2, 14, and the carry forward goes away. I'm not interested. 7 into 2, 14, that gives me the unit digit. Right? So what I want you to say is the unit digit of this is going to depend on just the unit digits. And I'm not interested in the rest. So this is same as the unit digit of 7 into 2. And while 7 into 2 is 14, I'm again not interested in that 1. This could be a big number I know out over here. I'm interested just in the 4. Hope you get this, right? And this is not just limited for 2 of them. Let's say I wanted to multiply this further by 209. Right? Now, I don't have this number. It doesn't bother me. I have to multiply with the 209. 9 fours are 36, and then I don't know these numbers. They will result into something values which I am unaware of. I'll put a hyphen, a dash out over here, and then the rest of the numbers. When I add them up, this unit digit is just going to be 6. Right? So, again, the unit digit is only going to depend upon the unit digit of the multiplicants. And once I know this is a big number ending with a 4, I know the unit digit. So, multiply it with a 9, 9 and 4 will give me a 36. That 3 is not the accurate number. We just ignore it, carry it forward into the tens position, right? The unit digit has been found out. So, what am I saying is, the unit digit of any product is nothing but the unit digit is dependent upon the unit digit of multiplicants. Let me say is not equal to, it depends upon, right? Unit digit of multiplicants. So there are different multiplicants, just worry about them. It's an easy point, I don't need it to reiterate it. A raised to b, for example, let's just say 128 raised to n. I want to find the unit digit of 128 raised to n. Now remember, this 128 raised to n is eventually 128 into 128 into 128 and so on n times. This is also a product, and here I want the unit digit just, right? So it will only depend upon the 8, right? So this is same as the unit digit of 8 raised to n. I am not interested in anything further, right? That is the message of this particular part out over here, right? So what that means is, if I want to find the unit digit of any power, I just need to learn the unit digit of a single digit. The unit digit itself raised to n. And how many different values of unit digits are possible? There are only 10 possible values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I just need to do that much work. So let's get started and learn. A lot of them are very, very easy as well. We just learned that whatever the base may be, we are interested in only the unit digit of the base because we want to find the unit digit of the product. And the unit digit of the base could just be these 9 possible values. So let's find a few of them are very easy. We know that 0 into any 0 is 0 itself, right? So this is a 0. So the unit digit of 0 raised to n will always be 0. And so on. We also know that 1 into 1 is going to be 1 itself. So you multiply any number of times any number 1, whatever the value of n is, the unit digit of 1 raised to n will be 1 itself, right? Is it same for 2? Not really. 2 into 2 is not going to become a 2, right? So we'll leave this for a moment and see, is there any other easy one out over here? 3 into 3 is a 9, which is not a 3. Why are we doing 3 into 3? Because it's 3 raised to n. So 3 multiplied with a 3. 4 into 4 is a 16, the unit digit is 6, which is not same, but we know 5 raised to n is nothing but a 5, right? So if you want to have a look at this, remember 5 raised to 1 is a 5, 5 square is a 5 into 5, 25, 5 cube is 125, 5 raised to 4 also you would be knowing. This into 5 is a, so when you multiply with a 5, I am interested in this 5, that's it. But you know the entire number 625. 5 raised to 5 is also nothing but 3125 is a 5. I do not know 5 raised to 6. But when I multiply with this 5, I am pretty sure that the unit digit is going to be 5, right? That is what was happening earlier also, but they are too small a number to even do any calculation. So 5 raised to n is always going to be a 5 for any natural value of n. Remember, the whole topic is related to a and b being natural numbers. But what if I do 5 raised to 0? 5 raised to 0 is going to become 1. Watch out for that. Or 5 raised to half, this topic is not related to that. 5 raised to half is a square root, right? It's a irrational number. In decimal form, they'll be huge. We are not interested in those type of numbers. Any other easy one? Yes, 6 raised to n will also end with a 6. And these are going to be different. So, 4 out of the 9 are so silly questions out of there, right? 2 more are very easy.